Hey yo, this is your Dragon CS student. Welcome back. So you might have noticed that I took a few days off. I actually just came back from overseas, from China, where I had a great trip with my friends. It was a lot of fun. Then I came back and yeah, I was greeted with some bit manipulation problems, and I was really tired, so I didn't really solve them. But to be honest, I really need to memorize the saw properties so that I could solve legal problems or if they come out interviews. Then on Saturday, I actually went for the NUS Hack and Roll. I just how should I say, I'm a lazy participant if you will. Didn't really do anything but just went there for the vibes and look at the listen to the career talks and whatnot and see the projects that other people build. Right. Anyway, I was a solo developer, just a one member team if you will. And on that day, I managed to solve this problem, which is our LeetCode 1368. Um, yeah, quite proud. Managed to solve this one. I didn't really do a video, but if you want to know like the general gist of the problem, spoiler, okay, it's basically a graph problem. You can use Diction to solve it. There are also other methods that I have to read about. So yeah, and then yesterday, sorry, I'm a little bit sick, but yesterday this problem is super cracked. It's super hard. Even the first version, Trapping Rainwater 1, it's quite hard. And then Trapping Rainwater 2 is like super cracked because in the original Trapping Rainwater 1, it was 1D. Well, Trapping Rainwater 2 is now 2D. So anyway, that's enough. Oh, all right. I was interrupted just now. Looks like the room that I'm in might be used. I don't know. We shall see how it goes. Anyway, yeah, as I was saying, let's move on to the problem of the day for today. All right, first completely painted row or column. LeetCode problem 2661. So you're given a zero index integer array R and an m times n integer matrix. Okay, mat R and mat both contains all integers in a range of 1 to m times n. Go through each index I in R in the array starting from index 0 and paint the cells in mat containing return the smallest integer return the smallest index I at which either a row or column will be completely painted in mat. Okay, to be honest, I really don't know what this question is asking, so let's just see some examples. Array 1342. 1423 exclamation output is 2. Okay. Rows are shown in order. You paint 1, then 3, then 4, then finally 2. On both the first row and the second column of the matrix are fully painted at this index. So you somehow return 2. Okay, return the smallest index at which either a row, okay, or a column is completely painted. Okay. I see. Okay. So they want to return so we have to process the array and return the smallest index at which if we paint that cell, right, then that is the we care about the index at which we completely paint an entire row or entire column. That's what the problem is asking, right? So let's see example 2. Next tree, okay. Paint 2, you paint 8, 7, 4, and 0, 1, 2, 3. This is the index in which a column is completely filled. Okay. 10 power 5, 10 power 5, okay. Yeah. Alright, so not sure the best way to do it, but essentially what I'm thinking of is you definitely have to keep track of, for example, you have to iterate through the matrix and you have to know, like, for example, like And let's say I'm painting 1, right? I need to map this value to its matrix position. So for example, like the value 1, I'm mapping it to, in this example, in example 1 with 0, 0, and the value 2, they will be mapping it to 1, 0, something like that, right? And all integers in a range, I don't think, did they say it's unique? Should. Yep, all integers that are unique so that we can create a mapping. So we definitely need to keep track of the information so that we can, paint the matrix in all one time. Then the problem is, how can we detect if a column or row has been fully painted, and at which point we want to break off the loop and return the answer, right? So we can say something like, for I in range of something. Oh, okay, sorry. Let's not move on to implementation yet, right? So like, how can we detect that? Well, the initial thought that I have in mind is you just keep track of the rows and the columns that have been painted. And when we do that is you can use uh, what's that? A hash set, right? So for example, you can have like a row set and a column set, right? How should we do this? Uh, so every time when we paint, for example, let's say we are painting 0, 0. Okay, we want to say, what do we want to say? So we can say in row 0, right? Let's just do the row example first, right? So we have like we are map. So this is another hash map, again another hash map, and we're mapping, for example, the row that's being painted to how many rows that has already been painted, if that makes sense. So for example, we can say like, oh, we map 0 to a set of uh, 0, 1, and 2, and this will represent its columns. So if using example 1, then this means that uh, at row 0, right, at column 0 and column 1, they are not being painted. And then here we can do another example, which is like this. So once we painted a particular cell, we can remove from the set in one time. And all we have to do is every time we paint a cell, we just check, hey, is the row that we just painted, is the length 0? If the length of the set is 0, that means, well, we have painted at least an entire row. So we do the same thing. We do the same thing for the columns. So, maintain like a set, let's say at column 0, right, at row 0, row 1 is not being painted, so for so on and so forth. So I think I'm going to go with that approach. The time and space complexity would be, well, we have to iterate through the matrix to map it initially. And afterwards, we're going through each array, and we can potentially exhaust the entire array before we, is that possible? Before we paint like a row. It's possible. It's possible. You can imagine a case where your matrix is just like a single list. How should I say? Like it just consists of one column, one row and a lot of columns, and then your array where you have to literally paint every single cell before you find the index in which like you paint the only and entire row. So that would take basically time complexity would be O array plus matrix, and then the space complexity is, well, it's actually quite a bit, because first we maintain the information of the matrix and what the mapping of the values to its matrix, to its matrix position. That's one, so that takes a whole matrix of time. And then we are doing another hash map when we are tracking whether a particular cell is being painted. So that also takes up matrix time. So I think this is the time and space complexity. Could be wrong, but anyway, let's get down with implementation. So let's do the first step first. Right, so this would be step 1, map values to matrix positions. This is step 2, which is paint cells and check if a row or column is fully painted in a greedy manner. Right? Should I leave examples here? All right, let's put it out somewhere so that it doesn't get too messy. I will leave the space and time complexity there though. So yeah. Okay, so first step, map values to matrix positions. So we have like a hash map, what should I say, a map. You just call it a dictionary, right? And I like to do it and as the rows, but it doesn't really matter. Length of matrix 0. Right, so for I in range so iterate through the matrix and we map the uh, matrix value, which is like this, to its position, which is like this. Now that's step 1, we have the matrix, we map the matrix values to its position. Now we have to paint it, right? So for, oh no, we also have to do another initialization, which is the row set. Correct, row set. Sure, I guess. Row dictionary, I guess. Not like this. Column dictionary. This allows us to check whether like a particular row or column is fully painted by checking the length. So I would say something like, can we do that during the initialization as well? Let's see. Yeah, probably. Yeah, maybe, yeah, let's do it step by step, okay? All right, so for the row dictionary, it's kind of like the same here, right? Just that row D of I, this new set, and here row D of I dot at J. But for the columns, it's a little bit different. For the columns, let's say something like this, right? It's column D, I, at J. Okay, let's see if that is correct. So if it's 1, 2, 3, let's say it's 3 by 2. Let's say it's 3 by 2, right? Should I? Yeah, X is fine. Just walking through a dry run so that I'm actually mapping the values correctly, because yeah, don't want to make any careless mistakes, right? So it's like this. The values don't really matter. So n is equals to 2, n is equal to 3, 3 at j. Yeah, this is correct. Okay. So after this, we will say for cell in array, right? xy is equals to d of cell, d of cell. Then we say, what do we want to do? We want to paint the cell, right? So to paint the cell, that would be row D of x dot remove the position. Wait, sorry. remove y. Right, remove y. Then column D of y dot move x. So if the length of row D is equals to 0, or length of column D of y is equals to 0, we return the index. So we actually need the index in the enumerate of array. Return the index. Now we shouldn't reach this point because we always have an answer, right? Yeah, I believe we always have an answer, so we shouldn't reach this point, but let's take a look. Oh, matrix is not defined. Maybe it's easier to just change it here. Okay, so I got accepted. Is this the best way of doing things? Is this the best way of doing things? Let's check for the empty case. Is there a situation where LeetCode is trying to be funny? Is index out of range? Invalid test case. Okay, so that's at least one. We can always do this, I guess. Okay. So we don't have to enter the empty case. It's guaranteed that our matrix has at least one row, one element. I'm just thinking if like there's like a way of doing it more optimally. You probably can just compress this somehow here. You can probably compress that somehow here. But talking about those like of big O, I don't think you can, because you do have to keep track of the cell information. For example, the cell values and their positions. You also have to keep track of whether the entire row and the entire column has been painted. So no, I don't think you can. I think this is, in terms of big O, as good as it gets. I'm gonna remove this so that LeetCode AI don't pick it up. I'm gonna do a submit, and hopefully I didn't make any mistakes, and I didn't. Let's check the runtime complexity, which was originally here. N times m. Okay, yeah, so it's just bounded by mat. Space complexity also n times n in this case. Yep. Let's see what the editor has to say. Brute force, which is basically kind of like what I did. I just did a simulation here. Brute force optimization, optimize with counting. Yeah, okay. Reverse mapping. Wait, hold on a second. Okay, what does that even mean? Oh, they do the other way around, is that it? Oh, I see. That works too. Yeah, okay, so essentially what this solution is trying to say is that, well, I haven't read like the entire intuition, but just from reading the code, what they do is they just paint everything, right? They just paint everything. Where do they? Where's the painting part? Oh, maybe I'm wrong. Map the array value to its index. Okay. And you have a result. Index value. Okay, maybe maybe I don't have like super clear understanding, but just based on intuition, what they're trying to say is I believe they are just painting everything and somehow they are able to reverse engineer which row or cell is first painted by like having some sort of timestamp, I believe. Let's see the slide. Maybe the slide will be better. Uh-huh. Okay, no, not really. But anyway, okay, I see. So actually our approach is more akin to approach two. So brute force with counting. Okay, sure, I guess. Oh, I see. Yeah, so technically you don't need a row D or a column D because the values are guaranteed to be unique. So in that case, you just need to track for every row and every column how many of it has been painted already, and if what, and if at any point in time the row or the column that you have just painted is the one that is being painted, then you can just return I. I see, I see. Yeah, this basic. So my solution is basically approach two. All right. Anyway, that's all from me. Gonna get back to grinding other problems. Uh, Especially reading up Trapping Rainwater 1, which has been on my to-do list since forever. Then I'm going to be Trapping Rainwater 2, etc., etc. Anyway, that's all from me. Have a good one ahead and happy grinding. Peace.